Alrighty, geometry students, it's Mr. Pouts here. I am here to walk you through section 1.5, day 1. So 1.5a, we'll do the second part of it in class. And there are a few different things that I like to talk to you about, and they're all dealing with angle pairs. So we talked about classifying angles and measuring angles. Now we're going to talk about some angle pairs. So if you want to write down the goal, please do. It says it's to identify special angle pairs and use their relationships to find angle measures. Okay? So we first got some definitions here that I'd like to talk to you about a little bit. And we'll go one by one here. So the first one is called adjacent angles, and I think the pictures help you probably the better than anything else. So adjacent angles, I'll try to write the definition here. It's a little bit long, but it's also in your book. Adjacent angles are two coplanar angles with a common side a common vertex, and here's an important part, no common interior points. So there may be an example where they have a common vertex and a common side, but like one is inside of the other. That would not work because they have common interior points. So two examples here. We have both angles 1 and angle 2 would be adjacent because it's basically angles that are right next to each other, but not overlapping. So there's right here we have angle 1 and angle 2. Angle 1 and angle 2 have they're on the same plane. They have the same common side. That would be the side right here. That ray. Common vertex. So vertex I'll show you in red. And there's no common interior points, meaning all the points in the interior of angle 2 are separate from all the interior points of angle 1. Same thing would go with angles 3 and 4 there. So those are adjacent angles. The next term we have is vertical angles. Vertical angles we're going to be using a ton, so get used to it. Vertical angles are two angles whose sides are opposite rays. So I think the best way to describe this to you is the picture over here. So the sides are opposite rays. So we have angle 3 and angle 4 are vertical angles. They're basically opposite angles. The two sides of angle 4 would be the opposite rays of the two sides. So we have this side is opposite of this side, so the opposite of that side. And then this side would be the opposite ray of this one. Okay? So that's how it works. We also then have angle 1 and angle 2. Those are also called vertical angles. We're actually going to have a postulate, I think, soon that are talking about vertical angles. Might be a theorem, but we'll get to that. Complementary angles are something you should have learned before. Their measures add up to 90 degrees. Okay? Two angles whose measures add up to 90 degrees. Okay, those are complementary angles, and we have here some here. It could be two angles and a right angle, because we know right angles add up to 90 degrees. It could be two totally separate angles, as long as they add up to 90 degrees here. Okay? And the last one you could probably guess are supplementary angles, and that would be two angles whose measures add up to 180 degrees. So two angles right? And two examples are over to the right. Um, if they are, well, we'll talk these. Sometimes they're adjacent angles. So we have right here, 3 and 4 would be adjacent angles. There actually isn't one for. Oh, well, actually, yeah. So there, it doesn't look like this one over here. We have to extend this, I think, to have the other part of that supplementary angle here. But 3 and 4, they would add up to 180 degrees because that total is a straight angle. Straight angles add up to 180. So whatever 3 is plus 4 is would get you to 180, or the measures of those. All right, couple examples before we move on. Is the statement true or false? Use the diagram shown. Is the statement true or false? And explain. So we've got the diagram over to the right. I'll actually move this over so you can see the diagram. True or false? Angle BFD, angle BFD in the red, and angle CFD, we'll do this one in the green, are those adjacent angles? Well, let's take a look at the definition of adjacent angles. Do they share a common side? Yep, looks like FC is a common side, that ray. Do they share a common vertex? Yes, F is a common vertex. But they have common interior points. All of these points are common between the two angles, so that would make it not adjacent. So false, because common interior points. All right, next one. Angle AFB and angle EFD are vertical angles. Let's take a look. Angle AFB, so I'll erase this. Angle AFB and angle EFD. They look almost like they're opposite, but they have to have opposite rays for the sides. So we look right here. Here we have opposite rays, but these are not opposite rays. One is going here, one is going here. Those are not opposite rays. So no, this one is also false. And lastly, angle AFE and angle BFC are complementary. Let's figure that out. Angle AFB, sorry, angle AFE. Oh, it looks like these two angles are already labeled for us. Here, AFE and BFC. So they should add up to 90 degrees, is my question. So 62 plus 28. Hey, that's 90 degrees, so that would be true. Okay, so there we go. That one would be true. So that's angle pairs. Those are the types. So here we go. Concept summary. This is something that's important, and it's important just to know. You don't have to really do that much with it, but we got a couple practices with it. Some things you can assume and some things you cannot assume when you're looking at a diagram. When in doubt, look to see if there's any marks. But it says there are some relationships you can assume to be true from a diagram that have no marks or measures. There are other relationships that you cannot assume directly. For example, you can assume, so this is again, this is the good part, you can assume or conclude from unmarked diagrams. You can assume that angles are adjacent, so they're next to each other. You can assume that angles are adjacent and supplementary, and you can assume that angles are vertical angles based on the picture, even if they're not labeled that way. You cannot, however, assume, we'll put that in red. Cannot assume angles or segments are congruent unless they're marked. An angle is a right angle unless it's marked, or angles are complementary unless it's marked. Because complementary you can't tell unless you have a right angle. Alright? And if you don't have a right angle symbol, you don't know. So let's look at a couple here with this one. Let's say, can you make each conclusion from the information in the diagram? Well, A. Can we assume that angle CBD is a right angle? Well, if there's no markings, you better not assume it, because that says it right there. Uh, you cannot assume if it's a right angle. So let's see, CBD. CBD. It looks like a right angle, but no markings. So no. I hope you can read that. That says there's no markings. Um, letter B, segment DE is congruent to EF. Segment EF. Let's see. DE and EF. Now we haven't talked about these markings, but when you have if you have segments and they have this line through it, a single line means that any other thing that has a single line through it, little dash, that means that they're congruent. Now the same thing goes with angles. We have right here that that means a single loop tells you that anything else with that single little loop or arc there means that those are congruent. So this one, yes, because there are markings. Angle BCE, BCE, so this would be BCE. I'll erase this. Angle BCE. Can we assume that that's congruent to angle BAD, angle BAD? I don't think so. Without anything else given, we can't quite assume that just yet. Maybe we'll be able to prove that in the future, but for right now, nope. And angle B or ABD, sorry, ADB, ADB, and FD, right, FDE. So FDE, I think I did that right, are vertical angles. As long as they have opposite rays, so these would be opposites right here, these would be opposites right here, then yes, you can assume it. Okay, and that's one of the things you can assume. You can assume angles are vertical angles. Alright, so that's assumptions and non-assumptions. Now, the very last thing that I want to do for this is just talk about what linear pairs are. This is the last term for this first half of section 5. A linear pair is a pair of angles. So this is a term to know. A linear pair, it's, I guess it puts it together, it's a pair of angles whose non-common sides are opposite rays. So let's think about that. A linear pair is a pair of angles whose non-common sides, so I'm going to draw a picture here. Let's say I have this angle and this angle. The non-common sides, oh, nope, are opposite rays, okay? So they have to be opposite. So we have this vertex here. So this one would have to go over here. So the non-common sides are opposite rays. But these are both two angles. So this could be angle 1 and this could be angle 2. The two angles that form a linear pair form a straight angle. So if they are opposite rays, they would form a straight 180-degree angle here. I know my drawing isn't perfect, so I apologize. But a couple things that we know about linear pairs are that they are supplementary. If they are a straight angle, they are definitely supplementary. And they're adjacent. We just talked about adjacent angles and how they're like right next to each other. So these would definitely be right next to each other, and they would be adjacent. I'm going to take this and group it together and minimize it a little bit. Throw it on over here. Well, right next to, well, we'll put it over there. Okay, there's an example, and let's check this out. Let's do one example with that. We have angle ADB and angle BDC are a linear pair. So I'm going to draw a new one here. Let's just assume we have, this is our linear pair. So this is D right there. And we'll do point B, point A, point C. So angle ADB is 3x plus 14. So this angle is 3x plus 14. And this angle is 5x minus 2. What are the angles of the measures of those angles? So take a moment and pause the video if you like. I'm going to pause it for a second and just check my work. But pause it and work through this one, please. Okay, so what do you know about linear pairs? Well, we know they're supplementary. That's enough for me. That gives us a number. Supplementary means that they add up to 180 degrees. So these two angles, so we have 3x plus 4 and 5x minus 2. Those are going to add up to 180. So let's simplify. Let's solve for x, because that might help us figure out what each angle measure is. So since it's addition, we don't really need these parentheses. So I'm going to add those together. Add those together. Looks like I have 8x plus 2 equals 180. Did I do that right? This is supposed to be 14. So it should be plus 12. Let's do then subtract 12 from both sides. 8x is equal to 168. And then if I divide both sides by 8, divide both sides by 8, x is equal to, 168 divided by 8, goes in 2 times. I think it's going to be 21. Goes in 1 time, that's 21, so then 8. Okay, so it is 21. That's our x. But our question says, what are the measures of angle ADB and the measure of angle BDC? So let's go back. The measure of angle ADB equals 3x plus 4. 14. So 3 times 21 plus 14. 21 times 3 is 63. Plus 14 would be 77 degrees. Okay, there's one of them. Now the measure of angle BDC is 5x minus 2. So 5 times 21 is 2. 21 times 5 is 105. Minus 2 would be 103. And you know what? That works out nicely because they're supposed to add up to 180. And 77 plus 103, sure enough, that adds up to 180. So there's a good way of checking your work here. So that is our first section, starting with stuff about angle pairs. We'll go back here. And your goal from that section was to be able to identify those special angle pairs. We had complementary and supplementary, and adjacent and vertical angles. And we also talked about linear pairs in general. So we used their relationships to find angle measures. We're going to do more of that next time. So I hope you enjoyed the video, and we'll see ya.